In the remotest corners of our planet, where sunlight fails to penetrate and pressures reach unimaginable extremes, the deepest ocean trenches hold their secrets tightly. These are places untouched by human hands, places where life itself has been forced to adapt in ways almost alien to our understanding. But recently, from these very depths, a new mystery has emerged, a persistent haunting hum echoing through the abyss. It is a sound unlike any other, one that has captivated scientists and fueled speculation across the globe. The deep sea hum. The phenomenon first drew attention when deep-sea monitoring equipment, painstakingly deployed thousands of meters below the surface, began to pick up low-frequency humming noises emanating from ocean trenches worldwide. These sounds are not random. They possess a strange consistency, a pattern that seems almost intentional, yet their true origin remains shrouded in darkness. They are reminiscent of the terrestrial Taos hum, a notorious low-frequency noise that has baffled residents and scientists alike in New Mexico since the early 1990s. But unlike the Taos hum, which is heard by a select few on land, these underwater signals travel immense distances, their frequencies capable of crossing entire ocean basins. What could be causing such persistent, enigmatic sounds? The first step was to rule out the obvious. Scientists compared the recordings to known geological activities: earthquakes, volcanic tremors, the grinding of tectonic plates. The hums did not match. Next, they explored the possibility of marine life. The ocean is home to a cacophony of creatures: whales, dolphins, fish, even crustaceans, each with their own distinct acoustic signatures. But the deep-sea hum remained a stubborn anomaly, eluding all attempts at classification. One of the most intriguing discoveries came from the Western Pacific, near the Mariana Trench, the deepest place on Earth. In October 2014, monitoring equipment detected what would later be called the Western Pacific biotwang. This acoustic signal begins with a low-frequency moan, building into a high-frequency, twangy noise. Further investigation revealed it likely originated from Bride's whales, a species known for its unusual vocalizations. Yet even this remarkable find did not account for the persistent hums detected in other trenches, or for the patterns that seemed to defy explanation. The mystery deepened. Some researchers began to speculate about the existence of previously unidentified deep-sea creatures, beings so elusive, so perfectly adapted to the abyss, that they have escaped detection until now. Could these sounds be the calling cards of colossal, undiscovered animals, communicating across vast distances in the way only the ocean allows? Or were the hums the result of massive geological processes taking place far beneath the sea floor, mechanisms so powerful and so alien to our current understanding that they manifest as these persistent, low-frequency vibrations? As the data accumulated, patterns began to emerge. The hums exhibited regular intervals, rising and falling in intensity, sometimes remaining constant for days, only to vanish and reappear weeks later. This predictability fueled further speculation. Some scientists saw echoes of planetary processes, perhaps the shifting of vast underwater currents or the subtle movement of deep-sea sediments driven by forces we have yet to name. But here, at the frontier of marine science, certainty is elusive. The deep ocean is Earth's last true wilderness, a realm where every dive promises revelations stranger than fiction. For now, the hum remains a tantalizing riddle, a signal from a world that refuses to be fully mapped or understood. Cutting-edge research continues. Oceanographers deploy ever more sensitive hydrophones, capturing the slightest whispers from the abyss. Advances in acoustic technology allow scientists to filter out background noise, revealing the hum in unprecedented clarity. Computer models attempt to simulate the conditions that might produce such sounds, exploring everything from the collapse of deep-sea methane hydrates to the resonance of submerged geological formations. And with each new piece of evidence, the boundaries of our knowledge are pushed further outward into the unknown. What does it mean that these hums persist, undisturbed by the passage of time, unaffected by storms or tides? Are we listening to the heartbeat of the planet itself, reverberating through the water columns and echoing against the trench walls? Or is this the language of life, creatures so ancient and so singular that their voices have never before reached human ears. Consider the parallels to the Tao's hum. On land, the mysterious noise has defied explanation for decades, with some attributing it to industrial sources, others to geological phenomena, and still others to the quirks of human perception. Yet in the ocean, the stakes are different. Here, the hum is not a mere curiosity. It is a clue, a thread that might unravel the story of our planet's most inaccessible domain. To study the deep-sea hum is to challenge our assumptions about the ocean itself. It is to acknowledge that the majority of our world remains unexplored, that even in the 21st century, the ocean's depths are full of surprises. Every new discovery forces us to reconsider what we think we know about life, about geology, about the very nature of sound and communication. The implications are profound. If these hums originate from unknown species, what other forms of life might be waiting to be discovered? If they are the product of geological processes, what does that reveal about the history and future of our planet? And if, as some suggest, they are a combination of both, life and geology intertwined in a complex symphony, then we are witnessing an interaction more intricate and awe-inspiring than anything found on dry land. As research advances, the scientific community remains vigilant. Collaborative efforts span continents and disciplines, with biologists, geologists, and physicists working side by side to decode the signals. International expeditions venture into the trenches, collecting samples, mapping topography, and testing new theories. Each mission brings us closer to the heart of the mystery, yet also reminds us of the vastness of what remains unknown. In this age of exploration, where satellites can map the surface of distant planets, the ocean's depths stand apart, unconquered, unyielding, and full of secrets. The deep-sea hum is a beacon, calling us to look deeper, to listen harder, to question everything we thought we understood. It is a reminder that the ocean is not just a source of wonder, but a frontier of discovery, where impossible truths await those bold enough to seek them. And so we listen, we record, we analyze. The hum continues, a constant presence in the background, at once familiar and alien. Its patterns persist, its origins remain hidden. But for the scientists and explorers who devote their lives to the ocean's mysteries, the search is far from over. With every dive, every analysis, every moment spent in the company of the unknown, we inch closer to revelation. For in the darkness of the trenches, where the pressure of water is matched only by the weight of possibility, the deep-sea hum is both a challenge and an invitation. It whispers of things unseen, of worlds yet to be discovered. And as long as it continues, so too will our quest, to reveal the impossible truths of the ocean's most mysterious depths, and to uncover the secrets hidden in the hum of the deep.